Well, in the end, let's look at a simple one. So in this one, we're not requesting you to calculate shear stress, so only normal stress. But here you have some points, okay? So how to determine the correct distance from the point of concern to the neutral axis. This is the difficult part in this one. And it also represents a different case. You just need to know. Okay, let's look at this example. A beam with a rectangular cross section is subjected to a force, this one force P, but this force has an angle with the x-axis and showing in the figure. Okay, in this figure, you have the x-axis here, y-axis here, and z-axis here, right? And this P is added to this end as shown in this figure, and you have an angle theta equals 30 degree. Okay, it's just not along x direction. It turns down towards the negative y direction with the angle. Right, so this force P can just be split into two components. One is along x direction, another is along y direction, right? Py. I just need to determine this two, split this P into Px and Py and use them to find out the internal forces and then normal stresses. Okay, so you're requested to determine the normal stresses at 2 points, H and K. And the H and K has been shown here on the cross section. And other dimensions, BH, E1, E2, L1, L2 have all been given. So just look at this one. The first step, again, we need to determine the internal forces. Right, but first of all, we need to determine the external loading, right, the forces. The first step, external and internal forces. Okay, since the P has been given, so what is the Px? Px would be P times cosine 30 degree, right? So this will be 2,165 pounds. And Py will be P times sine 30 degree. Right, so that will be 1,250 pounds. How about Pz? Pz equals 0, right? No components along z direction. So you have only two external forces, right? Let's analyze the internal forces using the table. Okay, draw a table. You have only two external forces, so just Px equals 2,165 pounds. Py 1,250 pounds. Okay, so which one is the axial direction? The axial direction with respect to this cross section on YZ plane. So the axial direction will be x. So you have f x. Okay, you will have a vz and a vy. How about vz? Do you have vz? Since you don't have loading along z direction, right? So no vz at all. But let's write it here. Okay, vz is just 0. Okay. So here you will have fy, fx. So px will contribute to fx, right? So that will be 2,165 pounds, and here contribution is 0, right? So Vy, one component, right? This negative py, right? Negative 1 to 50 pounds, since this py is along negative direction of y-axis, right? So how about the vz will be 0, right? No component at all. How about tau x, tx? Since we have determined that the x is axial direction, so the moment about x will be a torsion, will be a torque, right? So the tx will px make a torque? No, parallel, right? Parallel. So this is 0. So how about py? Will py make a tx? Yes, right. So what is the arm? The arm is L1 or L2? L2, right? So py times L2. Okay, so this is what? 1 to 50 times 24. This is 30,000 pound-inch. Positive or negative? Use your right-hand rule, you can find out that this is a positive value. Okay, this is a positive one. Then how about my? My. Does px make a my? Px? Yes, right? So what is the arm? L1 or L2? This will be L2, right? So px times L2. This is 2165 times 24, or 51,960 pound-inch. Does py make any my? No. Parallel, right? Parallel 0. Right? How about mz? Do we need to examine the mz induced by this px or py? Even though we do not have that, even though we do not have vz, right, but the px or py are positive, are possible to induce some bending moment about z direction. Right? We need to examine this. So which one will make mz? Which one make mz? Px or py? If you look at px, the px will go through z-axis, right? So the arm equals 0. So here arm equals 0, so it's 0. But the py will make mz for sure, right? It's the py times, what is the arm? L1 or L2? This time is L1, right? So this is 1250 times 40. You get 50,000 pound-inch. Okay, so far we have got all of these internal forces. Then we can start to check the normal stresses as requested, determine the normal stresses at these 2 points. Let's look at normal stress at point H first. Okay, so here it will have 3 components. Well, obviously 3 components. The first component is due to Fx, due to the normal loading, and the second one is due to My, and the third one is due to Mz. Right, the Tx will not make any normal stress. Right, so only 3 things. Only 3 internal forces is possible to make normal stresses at the 2 point. This is the first one, second one, and the third one. Right, we just need to determine these 3 things. So the first component at point H will be just Fx over A. Right? The Fx is 2160 over the A is just B times H. Right? B is 8. H is 6. Right? So you get 45.1 psi. And the second one will be second component at point H will be due to the bending moment My. Y times YH1 over I. Right. So here we just need to know what is a YH1. What is the Y value we'll need to use for this calculation. Right. Let's look at this figure here. Your point H is here. When you have My, right, when you have My, what is the distance? YH. Right, what is the distance from point H to the neutral plane? That will be, so here the YH1 will be what, half B minus E1, right? Half B minus E1. B is 8, so 4 minus E1 is 2. Right? E1 equals 2, E2 equals 1. Is that correct? Yes. Here is 8, H is 6. Okay. So here it would be 2. So how about I? The I here will be BH cube or HB cube over 12. Okay, here when you're talking about My, obviously the H will be the bottom and B the height, right? So here this I will be IY. I with respect to y-axis will be HB cube over 12. Or 6 times 8 cube over 12, right? So here it would be 256. Okay, so now this equation, you just get the numbers in the equation. Here is IY, right? So will be MY as just determined 51,960 times 2 over 256. Okay, you will get 406 psi. Positive or negative? Positive or negative? My. What is the direction of My? So, okay, My will my is due to px, right? pxl2, pxl2. So it will be turn it. So what is the sign at this point? Positive or negative? Will be negative, right? So the px times L2 will tend to turn it in this direction. So your point H will be in compression, right? So here is it's a negative value. So how about the other components? Due to bending moment mz, so this will be the sigma 3 h equals mz yh2 over iz. Right? So the mz, as we just determined, is 50,000. 50,000 times, what is the y? yh2, this distance from h to the neutral axis to here, this time, right? This is the distance. Okay, so that is just half h, right? Half h. So here, our yh2 will be half h, or 3. How about iz? Iz will be this time just bh cube over 12, right? Or 8 times 6 cube over 12, 144. So we'll have all the numbers that we need, times 3 over 144. Okay, so you will have 1042 psi. Is this positive or negative? So mz is py, downward py times L1. Right? Downwards py times L1. And it will be bending it in this way, right? So the h will be on the top of this cross section, right? So it will be in tension. So this will be positive. Okay, so the overall stress at point H, normal stress, will be just adding the 3 numbers together. The first one will be a positive value, 45.1 minus 406 plus 1042. Okay, so we got 681 psi. Okay, so this is the normal stress at point H. So the third step, we will examine the normal stress at point K. You just follow the same schedule, okay, the same procedure, to find out that the first component at point K, that will be the same, right? The same as the point H. This is just a normal stress due to axial loading. It will be 45.1. And the second point, the second component will be the second one at the point K, due to my times y k1 over iy. Okay, iy we have known, so just determine the yk1. What is the yk1? The point Point K is right here. So when we examine YK1, when you have MY, okay, the distance is here, right? So that is half B, right? Half B or 4, okay? So here will be YK1 is half B or 4. So here we will have 51,960 times 4 over 256. That is 812 psi. Positive or negative? Okay, you can do this analysis by yourself, and I can tell you that this result will be positive. Okay, this time is a positive. Let's use the red color again. This is a positive value. How about this third component at point K? We have mz yk2 over iz. Again, you just need to find out what is the iz will be the same, 144. It's just what is yk2. K is here, so yk2 is just from the k to the y-axis, right? So what is this value? It's just half h minus e2, right? Half h minus e2. This would be 6 over 2 minus 1, 2. Okay, so we get 2 here, and the result will be 694 psi. Again, you are requested to analyze the sign by yourself. Try to find if that is positive or negative. Okay, I tell you the result is negative, but you need to figure out why it's negative. Okay, so the final result, normal stress at point K will be a combination of all of them. You get a 45.1 plus 812 minus 694. Okay, you have 163 psi. That's it.